So today I want to talk about quadratic equations with three variables. Quadratic meaning that the highest degree is exactly equal to 2. Let's begin with an example which should be familiar. Let's look at x squared plus y squared is equal to 1. We should definitely know what this looks like in R2. This is just the unit circle. But there is no dependence on z. Z can be whatever it wants, which means that this circle can be extended infinitely upwards and downwards. One way to define a cylinder is by taking a circle and moving it up and down along some parallel lines. Something like this. So you're moving the circle up and down, and all the lines being formed are parallel to each other. These lines have a special name. These are called rulings. But that's not really important. What's important is that all the rulings are parallel. Now, we call this a cylinder, but the more technical term for this is a circular cylinder. Because there are other kinds of cylinders. Let's see another example. For this example, let's graph the equation x squared minus 2y minus z plus 1 is equal to 0. Now, the first thing is that if we want to graph it, we usually like to solve for z. That is generally how we think about these. We get z is equal to x squared minus 2y plus 1. All we did was just rearranged this equation, sorry. So, now, if y is equal to 0, let's look at some special cases. If y is equal to 0, we're just looking at z is equal to x squared plus 1. And when y is equal to 0, another term for that is the xz plane. So, let me draw my axes. And let me draw on the xz plane z is equal to x squared plus 1. So here's plus 1. And it's some parabola that's shifted up by 1. Now when y is equal to 1, z is equal to x squared. Now we are taking into account the y minus 1. So if we go out 1 on the y-axis, then the graph gets shifted down by 2. But other than that, it's the same parabola. And again, let's go out one more in the unit of y. If y is equal to 2, then z is equal to x squared minus 3. So if I go out another unit in y, now I have to go down 3 units in z. And I get my parabola. And now if I connect this up, I get some sort of and so it looks like a folded sheet of paper folded into a parabola. Now, if you notice, you can also think of this as a parabola that's been shifted in this direction along these rulings, just like the cylinder. This shape, in fact, is called a parabolic cylinder. It's another type of cylinder, but this time the generating shape is a parabola. So cylinders are not just circular cylinders. There can be any sorts of cylinders. Let's do one final cylindrical example and look at the graph of y squared plus z squared minus 4y minus 2z minus 4 is equal to 0. Now, you'll notice, first of all, that this equation has no dependence on x. And second of all, we have a y squared and a minus 4y and a z squared and a minus 2z. So we're going to want to do completing the square twice. For the y squared minus 4y, well, we're going to need to add 4. So let's add 4 to both sides, and then we're going to end up with y minus 2 squared. And for the z squared minus 2z, we're going to add 1 to both sides, and then we're going to have z minus 1 squared. And then we have minus 4. Let's add that to both sides. And is equal to 9. So after completing the square, we see that this is the equation of a circle, which is depending on x, on y and z, which is centered at 2, 1, and with radius equal to 3. And so if we draw our axes, we can graph this. We go over 2, up 1 in the YZ plane. There's our center. And let's go over 3 in all directions. Draw a nice circle. Let's do this in salmon color. And then we know that there's no dependence on x, so this stretches out the positive and negative x-axis. There we go. It goes on forever. We can define a cylinder in the following way. A cylinder is a surface generated by a curve generated by sliding a curve along a line. So you can have circular or elliptical cylinders. You can have these parabolic cylinders. You can have cubic cylinders. So it looks like this. All of these are examples of cylinders. These hyperbolic cylinders. Something like that, and they would just continue on forever. These are all examples of cylinders.